how do we add, subtract, and multiply matrices? Let's answer these problems. We're seeing 5 matrices, matrix A, B, C, and D, and we're going to be performing the operations, 6 operations that we have here in our lesson. But first, write the order of each of our matrix. And for matrix A, this is an example of a 3x1 matrix because we have 1, 2, 3 rows and 1 column. So make sure that you remember that the order or dimension of the matrix is not commutative, so it needs to be row and then column when you order a matrix. So for matrix B, we have a 2x2 matrix. Matrix C is an example of a 2x2 matrix, and matrix D, which has 1, 2 rows and 1, 2, 3 column, is a 2x3 matrix. And the reason why you need to know the order of each of these matrices is because you're not going to be able to perform some of the arithmetic operations that we have here in our example based on the rule that we're going to be working on today. So let's start with 2A, which is basically multiplying matrix A, which happens to be 2, 3, and 6, and multiply the constant 2 to our 3x1 matrix. And by the distributive property, all we need to do is to multiply 2 and 2, 2 and 3, and 2 and 6, which will give us 4, 6, and 12. This is a fairly simple arithmetic operations, which is, we could say, one of the easiest operations when it comes to matrix arithmetic, and we call this scalar multiplication. And for the sake of discussion, for matrix A, B, C, and D, we can perform any scalar multiplications for each of these matrices, just making sure that we are using a constant to multiply B, C, or D. Now let's say we're going to be working on the other 6 matrices. Next would be B plus C. So we are going to be adding matrix B and C, which we know is matrix B happens to be a 2x2 matrix, and matrix C also happens to be a 2x2 matrix, which is important because when this happens, that means we can combine B and C by simple arithmetic or simple addition of integers. So we'll have 2 plus -6, 2 plus 5, 6 plus 3, 5 plus -2, and make sure that you know the rules of adding and subtracting positive and negative numbers, so you will end up with the correct sum of matrix B and C, which happens to be -2, 7, 9, and 3. Just remember that when you're adding or subtracting matrices, their order needs to be identical, or they need to be similar, so you can combine them by the operation of addition and subtraction. So this is the sum of B and C, and let's go back to our examples and proceed to problem number 3, which is C minus B. So we have matrix C, which is -6, 5, 3, and -2, and B, which happens to be a 2x3 matrix. So when this happens, a 2x2 subtracted with another 2x2 matrix, knowing that the orders are the same, that means we can combine C and B. So by subtracting them, again, make sure that you know your rule in addition and subtraction of positive and negative numbers. So -6 minus 5, 5 minus 2, 3 minus 6, -2 minus 5 will equal to -11, -3, -3, and 7. So this is now the difference between C and B. And again, knowing that the order of your 2 matrices are the same, you can perform subtraction and also addition of these matrices. Now for problem number 4, we have C plus D. So let's have matrix C right here, which happens to be a 2x2 matrix, and matrix D, which is a 2x3 matrix. And by knowing our basic rule of combining 2 matrices by addition or subtraction, we know that C and D is an empty set because you cannot add nor subtract matrices of different dimension or order. So this is a null set or empty set, and we're not going to be able to perform the operation of addition for C and matrix D. Now going to our problem number 5, which is multiplication of two matrices. So let's multiply C and D together, knowing that the order of the matrix right here for matrix C times matrix D is a 2 by 2 and a 2 by 3 matrix. You will notice that their order are not the same, but their product is not empty because their product is actually 4, -5, -61, -1, 2, and 28. However, I'm not going to show you how we multiplied matrix C and D, but we're going to learn first how we can multiply or not multiply, or when not to multiply two matrices together. And this is all because of your numbers in the middle, or your orders right here, which happens to be identical. So you have the same number of column on the first matrix and number of row on the second matrix. And when this happens, you can multiply C and D. And the dimension or the order of a matrix will also tell you the product or the dimension or order of your product, knowing that the outside number that you're seeing in your pairing is 2 and 3. So when this happens, product or multiplying two matrices is possible. So in this case, if we multiply them, knowing that 2 and 2 are the same, and that our outer number is a 2 by 3 or 2 and 3, the product will be a 2 by 3 matrix. So that's the first rule that you need to remember when you are taking the product of two matrices. And for the sake of our discussion, what if we're going to be multiplying AB, BC, DA, and AD? Let's see if we're allowed to multiply these pairings of matrices. Starting with A and B, we know that matrix A and matrix B are not the same, and the number in between them, which is 1 and 2, are also not the same. So that means this will be an empty matrix because you cannot multiply A and B with the rule that we had a while ago. So for B and C, B is a 2 by 2, and C is also a 2 by 2. We have an identical matrix in our inner circle, and the product of our matrix will be a 2 by 2 matrix. So this is how you determine if multiplication is allowed in the two matrices that we're combining based on this arithmetic or matrix arithmetic. So let's go with the third pairing, which is D and A. D is a 2 by 3, and A is a 3 by 1, even though their dimension or order are not the same. The middle value are the same, so that means the product is going to be a 2 by 1 matrix. And for the last pair, we have matrix A, which is a 3 by 1, matrix D, which is a 2 by 3, knowing that the middle value or the number inside the circles are not the same. So that means this is an empty set, and we're not going to be able to multiply A and D together. So in performing matrix arithmetic, make sure that you know the order of each of your matrix so that you will know if you can add, subtract, or even multiply matrices together. This is Dr. E, and see you again next time.